How does LLM latency challenge real-time applications? Imagine chatting with a customer support bot or getting instant coding help. Now picture waiting several seconds for each reply. That delay can really frustrate users. Large language models, or LLMs, are at the heart of many AI tools today. They help generate text, answer questions, and even create images. But their speed or latency can sometimes slow down these experiences. Latency is basically the time it takes for an LLM to produce a response after receiving a prompt. When you ask a question, the model needs to process your input and generate a reply. If this takes too long, the conversation feels sluggish. In real-time applications like chatbots or voice assistants, quick responses are key. Users expect almost instant feedback, or they might lose interest or trust. There are two main ways to measure latency. One is the time it takes for the first part of the response to appear. The other is how long it takes to generate each word or piece of text after that. Both matter because delays at any point can make the interaction feel slow. For example, if it takes several seconds just to start replying, the flow of conversation breaks down. Several factors influence how fast an LLM responds. Larger models with more parameters tend to give better answers but need more processing power. This means they take longer to generate responses. Hardware also plays a role. Using high-end graphics processing units or specialized AI chips can speed things up, but not all systems have access to this equipment. Network speed is another factor. When models run in the cloud, data has to travel back and forth, adding extra delay. The length of the input or conversation history also impacts response time. If a chat application keeps track of many previous messages, the model has more information to process. This extra data can slow down response times, especially if the input becomes very long. Sometimes the increase in delay isn't linear, meaning it gets worse very quickly as the context grows. Popular AI tools like ChatGPT, DALL-E, and Midjourney relying on fast responses to keep users engaged. If a coding assistant takes several seconds to suggest a line of code, it disrupts the workflow. Similarly, a slow customer support chatbot can make users impatient or abandon the chat altogether. To fix these issues, developers use different strategies. They might choose smaller models that respond faster when high accuracy isn't needed. Reducing the input length or batching multiple requests can also help. Caching previous responses avoids repeating calculations, saving time. Some platforms even offer versions of models optimized specifically for speed, making responses quicker for time-sensitive tasks. In the end, LLM latency is a big challenge for real-time applications. It affects how quickly AI tools respond, how smooth the experience feels, and whether users stay engaged. Managing this latency involves balancing model size, hardware, input length, and smart optimization techniques. As AI continues to grow more common in everyday tools, keeping responses fast will be key to making these tools truly useful and enjoyable.